Today we continue our lesson for the quadratic function. The general form of quadratic function is ax squared plus bx plus c. If fx equal to ax squared and a greater than 0, the graph is concave up and the minimum point at 0, 0. Otherwise, if fx equal to ax squared and a less than 0, therefore the graph is concave down and the maximum point at 0, 0. Therefore, the domain of the both function is from negative infinity to infinity. And the range of the first graph is from 0 to infinity including 0. And the range of the second graph is from negative infinity to 0 including 0. Next, if fx equal to ax squared plus bx plus c and a greater than 0, the graph is concave up and the minimum point at x1, y1 and intercept y-axis at c. And the second graph, if fx equal to ax squared plus bx plus c and a less than 0, the graph is concave down and the maximum point at x1, y1 and intercept y-axis at c. How to find the value x1 and y1? First, find the symmetrical line. The symmetrical line is negative b over 2a. Same for the second graph. And how to find the value of y1? Substitute the value x1 into the function. Therefore, the domain of the both function is from negative infinity to infinity. And the range of the first graph is from y1 to infinity including y1. And the second graph, the range is from negative infinity to y1 including y1. For example 5.4, sketch the graph of the following functions, hence finds its domain and range. Given fx equal to x squared minus x minus 2. We can determine the value of a, b and c by using the general form. Therefore, a equal to 1, b negative 1 and c negative 2. The value of a greater than 0, that means the function is minimum. First step to sketch the graph is to find the minimum point. We state x1 and y1. How to find the value of x1? Is from symmetrical line, negative b over 2a equal to negative times negative 1 over 2 times 1 equal to 1 over 2. Find the value of y1 by substitute the value of x1 into the function. Equal to 1 over 2 squared minus 1 over 2 minus 2. We calculate, we get negative 9 over 4. That means the minimum point at 1 over 2 negative 9 over 4. Second step, to find the intercept x. Intercept y-axis. Y-axis. The value of c is negative 2. And third step, to find the x-axis. from the function x squared minus x minus 2 equal to 0. You can factorize. Try to factorize this quadratic x times x and 2 times 1. Minus 2 plus 1. The x exists at negative 1 and 2. Now we can sketch the graph. X exists and y exists. Then plot the minimum point x 1 over 2 and y negative 9 over 4. Here is minimum point. And the graph is intercept y axis at negative 2. The graph is concave up. And intercept x axis at negative 1 and 2. Label the graph fx equal to x squared minus x minus 2. Hence, find its domain and range. The domain of the function is negative infinity to infinity for quadratic. And the range of the function refer at the minimum point from negative 9 over 4 to infinity. For example 5.4, question B, fx equal to negative 2x squared plus 3x plus 2 and given the constraint x greater or equal to negative 3 and less than or equal to 4. We can state the value of A, negative 2, B, 3 and C, 2. A less than 0, that means the function is maximum. To sketch the graph, we can state the maximum point at x1, y1. To find x1 is from symmetrical line negative b over 2a equal to negative 3 over 2 times negative 2 equal to 3 over 4. And y1 is substitute the value of x1 into the function. Negative 2 times 3 over 4 squared plus 3 times 3 over 4 plus 2 equal to 25 over 8 or 3.1. The second step to find the intercept y-axis. At the value of c equal to 2. And the third step is determine the intercept x-axis. Okay, from the function is negative 2x squared plus 3x plus 2 equal to 0. We can factorize negative 2x squared minus 3x minus 2 equal to 0. We factorize to the quadratic. 2x times x 1 times 2 plus 1 and minus 2. The value of x is negative 1 over 2 and 2. That means x exists at negative 1 over 2 and 2. Now we can try to sketch the graph. Plot the maximum point at 3 over 4 and 25 over 8. And intercept y-axis at 2. The graph is concave down. Before we complete the graph, the constraint is x greater or equal to -3 and less than or equal to 4. When x equal to -3, the value of y substitute -3 into the function equal to -25. And when x equal to 4, y equal to -18. The graph is intercept x-axis at -1 over 2 and 2. And at the left, x -3 and y -25. When x equal to 4, y -18. Now we can state the domain. The domain of the function is refer the constraint from -3 to 4. And the range of the function from the lowest -25 to the maximum point 25 over 8. Okay, done.